Welcome back to the programming language series where we're going to build a statically typed and JIT compiled language using nothing but Python and LLVM. Today, the main goal for this episode is to implement our first user-defined function, which is going to be our main function, and we're going to turn that into our entry point of our program in Lime. And we're going to also be running our program. So we're going to be able to have what we see on the screen. We're going to compile the main function, and we're going to, just for fun and games, declare a variable with a value of 4, and we're going to return that variable, and we're going to be able to see that after we run the program later down the line. So we got a little bit of coding to do. This may be one of the longer episodes, but we can get right into it with our token class. So we'll go to token.py. We're going to add a couple new token types. First one's going to be down here in the keywords. We're going to do fn. This is for our function. We're going to go down below the semicolon. You can put it actually anywhere you want, but I'm just going to set it here. Arrow. And this is for our typing right here. We'll put it over here for right now. So this is our typing arrow for functions. We need our left brace and our right brace. So these are our curly brackets right here. And then we also need our return keyword. So we'll put that down here. This is for our, basically our return statements right here. So down in our keywords, we will add fn, map that to the token type.fn. We will add return. We'll map that to our token type.return. And now for our Gen Z keywords, I do have a few I'm going to copy paste in for our function, return, and our arrow. So for functions, I'm going to use bruh, because why not? We're going to do pause for return, and then we're going to do this beautiful 3D thing. And I just saw this on the good old 4chan Reddits, and so we're going to use 3D for the arrow. Alright, this is me from future editing land. Sadly, we can't do that beautiful 3 minus D without some extra fancy parsing, and I don't feel like implementing that right now, so I feel like Snek might fit our arrows, so we're going to use that instead. So please disregard the 3 minus D, you know what I'm saying. Alright, now we're going to go to the lexer.py. We have our tokens set up. We need to add one helper function. It's called peakchar. It's pretty much the same as one of our peak tokens in the parser. So it's just going to peek to the next character at that read position and return it back. It doesn't advance anything, just kind of gives it back to us. We're going to go down to our next token function. We're going to add the case for our arrow. So it's going to be slightly different since the arrow also has a minus sign at the start. So what we're going to do is we'll Control X this. We'll put a little comment handle arrow. Now we're going to use our newly created helper function peakchar, self.__peakchar. If that's the next token is equal to the greater than sign. So for the end of our arrow, we want to save the current character to a variable. We want to advance the lexer, and then we want to set this token. I'm just going to paste this here. We're going to set the token to an arrow, and then on the literal value, we'll do our ch character plus the current one, which is now the arrow, or the greater than sign. So else, if it's not an arrow, we're just going to send back a minus and not increment the lexer at all. Next two things we're going to add is our left and right curly braces. So we'll go down here. We'll put them underneath our parentheses. I'll just paste them in. You can copy these. And that should be it for our lexer. So we can go to main.py really quick and turn everything to false. We'll do a true to our lexer debug, but we can run python main.py. So we do have a lot of parser errors, but we don't care about that. We're just trying to make sure we do not have any illegals. So we do have our arrow parsing, which is great, and our left brace and our right brace. So everything that we added is now coming through our return statement and our function. So perfect. So our lexer is pretty good, so we can toggle that off and go ahead and just set our parser debug to true for next. And we'll move into our AST.py. For the AST.py, the only things we're going to need are 3 nodes. So we're going to need a block statement and a return statement and a function statement. So just copy these down. Pause the video, copy these down. So the function statement's going to take care of all of this. The block statement is a new one. It's basically the list of statements that's inside curly braces. So later down the line, if statements will also have blocks. So they're just blocks of code that are signified by these curly braces. And the return statement's just as you'd think, just this return value right here. So now we can go define these nodes. So the first one we are going to define in our statements is our block statement. I'll go ahead and copy paste this just to save some time. All this block statement will do is take in a list of statements. If that list is none, it'll just default it to an empty list. Same type variable in the same JSON as before. You could copy this down if you need to. Next one we need to set up is our return statement. So I'll copy paste that one. So the return statement, all it does is it takes in an expression for its return value. So that's going to be this A, or it's a 5 or whatever the heck, 5 times 5, whatever it is. That's what this expression will be. And then same for the type and JSON functions, just as we normally do it. Function statement has a few more things to add. So we'll paste that in and I'll get rid of this. So our function statement takes in a list of parameters. We won't be dealing with parameters quite yet, so we're just going to keep this here for now. The next things are our body of the function, which is our block statement. We're going to have the name of the function, which will end up being an identifier literal, just because this statement is declared above the identifier literal. I can't use the type hints on this. And the return type. We set all these variables, and the type and JSON functions are pretty much the exact same as every other AST node. Now that we're finishing up in the AST, we can save that and go into our parser. First thing we need to do in our parser is import everything that we just built. So I will go up to the statements, paste that in. We want our function, return, and block statement. We're going to go down to our prefix parse functions. We're going to add a section for identifiers. So this is our token type ident, and we'll have a new function called parse identifier. So we can go down to the parse identifier place, down in our prefix methods. So our region prefix methods, we can just slap this up at the top. So def parse identifier self, and it returns an identifier literal. So we'll return identifier literal. The value will equal to the self.currentToken.literal. And that's all that function will do. So now we're going to go into the parse statement function. So we can scroll up to our statement methods. Here's our parse statement. We're going to add 2 cases to this. We're going to add one for our function and one for our return. So we're going to have a parse function statement and a parse return statement here. We're going to define all of these functions really quick before we implement them. So we'll scroll down to the bottom of this region. So def parse function statement. We'll take in a self. We'll return back a function statement. We will do a parse return statement self. This will return a return statement. We'll pass that as well. And our last function we'll define really quick is parse block statement. Take blocks in self, and it will be a block statement. We'll also slap a pass on that as well. First one we'll do is our block statement. So we'll take this out. We'll add a block statement variable, which will hold our base class of our AST. We'll increment to the next token. So while not self dot current token is token type dot right brace, and not self dot current token is end of file, token type dot EOF. We're going to grab a statement. So self dot underscore underscore parse statement. If statement is not none, so if there is a statement, we're going to append that statement to our block statement. We'll increment the parser. Then we'll return back this block statement. Now we'll move up to the return statement. And these two need to be defined before we can do our function statement. So that's why we're starting here first. So our return statement, like always, make a statement, initialize the class. We're going to increment the parser from that return keyword to get to our return value. So statement dot return value. Self dot underscore underscore parse expression, and we'll just do the p lowest precedence for that. If not self dot expect peak, so we're making sure a semicolon is on the end of that statement. If there isn't, we'll return none, and that will show a parser error. And then we'll return statement. All right. Now we can get into the fun one. So for our function statement, we'll start off the bat just initializing our AST class. What we're trying to compile, just so what we're trying to parse, is fn name, then we have parentheses, then we have an arrow, a type like int, we'll have curly braces, and then a list of statements inside of this. So for now, we'll just return 10 here. So this is the syntax we're trying to get. Right now we are on the fn keyword for function. So the next one we're expecting is a name or an identifier. So if not self dot expect peak, token type dot ident, we want to return none. We'll go ahead and copy this because we'll be using this a lot. So statement dot name is an identifier literal, and the value is that current token's literal. Next thing we're looking for is parentheses. So left paren, L paren. If we don't find that, it'll be none. For right now, we'll set the parameters equal to a empty list, and we'll slap a to-do flag on that. And then we need to do a right parentheses. We expect that after parameters. Right now, there'll be a function to grab all of these parameters and parse them out. So for now, we'll add this. In the future, we'll be removing this if statement, and it'll be replaced by this parse parameters function. Next thing we need after the right parentheses is our arrow. So we will paste this in again. We're looking for an arrow. Next thing we're looking for is our type. So we will expect the type keyword. If it's not, we want to return none. We'll set that return type equal to the self.currentToken.literal, because the token right now is whatever this type is, which in our example is the integer, the int. Next thing we're expecting is a left brace to start our block statement. So we'll paste that in again, left brace. Now we need to parse our body out. So self.__ parse block statement. And now we want a return statement after that. So now we can go back into main.py, make sure the parser debug is on. And we can go ahead and run our file and check out our ast.json. So we do have our function main. We have a block statement in our body. Return type was integer. We have a let statement in here, a equals 4. Then a return statement that's returning that identifier of a. So the function statement's parsing correctly. The return statement also is as well, and the block statement is as well. So that's perfect. So we can now move on to our compiler.py. First thing we'll do is just import everything we just made. So block statement, function statement, and return statement. We need to go to our compile method and add all three of these nodes into the case statement. So I'll paste these in just for the sake of time. So we're going to have a function statement which has its own visit method. Block statement has its own visit, and return that has its own visit. So the first thing we're going to implement is our block statement first. So we'll go into our statements region. So def visit block statement self node, which will be a block statement, and it won't return anything. And this is a really easy one. So for statement in node dot statements, we want to compile self.compile that statement. That's all the block statement does. So now we're going to visit our return statement next. So def __ visit return statement. Self node will be return statement. Won't return anything. So we're going to take that value out of the node, so that return value. We want to get the LLVM value and type of this expression. So we'll use our resolve value function and pass in our expression into that. And now we're going to invoke the return instruction, which is just self.builder.ret, and we'll pass in that value as what we want to return. That's it for the return statement. Now we can move into the more fun function statement. So def __ visit function statement self node function statement. Make that return none. So we're going to take the name, which will be a string. We'll grab that from our name identifier in our function node. We'll grab our body, which is a block statement, from the node.body. We'll grab the params list, which is a list of identifier literals, parameters, but right now that's not implemented, so it's going to be an empty list. I'm going to add a few more. I'm just going to paste these in for the sake of time. So param names, this will not be used until later. So I'm just going to keep it in here just so we don't forget. Param types also won't be used until later. And the return type just takes this node return type from the function statement and gets the correct LLVM type from our type mapping. So now we need to build up our LLVM function type and function. So the function type will take in our return type, which is an integer in this case, and our param types, which should just be an empty list. We're going to build our actual LLVM function, pass it in our module, our function type, and then the name of that function. So in this case, that would be main. We're going to make a block, the type ir.block. We'll take our function and append that block to it. We'll name it name _ entry. So this is our entry block. We're going to save our previous or our current builder right now to a variable so we can come back to it. We're going to set our compiler's builder to a new IR builder with the entry point of our block that we just created. We're going to take our previous environment and save that to a variable. Now we're going to set a new environment for this function. So self.env equals environment, and the parent will be our current environment that we have right now. We're going to define this function in our environment. So define the name, the function, and the return type. So that's going to define our main function within our environment, so we can't name anything else main. We are going to compile our body or our block statement. We're gonna, now after that function's been compiled, we need to reset back to our previous scope or our previous environment. So self.env equals previous env. We want to take this define function call right here and do it again on our environment. That way in our global environment we now have that main function in our scope as well, so we can now call that later down the line or make sure nobody else names another function called main. Now the last thing for this is to do a reset our builder back to our previous builder, which is our more of our global scope. And as we define functions within functions within functions, this will just recursively go down the chain of environments and scopes. So now that we have this function statement, we can go up to our visit program and get rid of all of this fake main function creation. So all this, everything except this for statement and node statements can go away. So this is all our visit program will do. It's pretty much exactly the same to our block statement function. And then we have one extra bug fix that I noticed. We need to go to our visit let statement. In our if statement right here at the very last, we put value here when this really needs to be our pointer, because this is our new allocation instead of just the value up here. So we need to change this value to pointer. And that is absolutely it for our compiler. So now we can go into our compiler or our main.py file. We can set this lexer or this parser to false. We can set the compiler to true. We can go ahead and run the program to generate our IR, and we can see, I'll grab our test.lime file up too as well. All right, so we have our main function that we defined here. We allocated an integer, we're storing 4 into that, we're loading 4, and then we're returning whatever's in point 4, which is whatever's in point 2, which should be 4. So that is completely it for compiling functions, but now we'll get into the actual, let's actually run this program with an MCJIT compiler. So for this, I'm going to add a run code flag. We'll set that to true as well. Set the compiler debug to false since we know that's running. We can go down here in our, at the very bottom, we can do if run code. There's 3 initialization steps we need to do. We need to make sure we have our LLVM imported. We need to make sure we have these C types imported. There's one last import. I want to import time. This is just for execution time, we'll see later. In this if run code block, we want to initialize 3 things. So LLVM.initialize, we want to initialize the native target and the ASM printer. We need a try except block now. Format all this. So we're going to try to parse the LLVM. This is just the stringified version of our module, which is everything in our IR file. So we're going to parse that to assembly, and we're going to verify it. If that raises some type of exception, we'll print that, and we'll break out, erase it. The next line of code, we need to set our target machine. Get rid of that. We need to set our target machine from our default triple. We'll create that target machine. Now we need our LLVM engine. So the engine we are going to use is the MCJIT compiler. So we'll create that, pass in the LLVM IR parsed and the target machine. Then we'll finalize the engine object. Now we'll get to our entry point of the function. So the function address, we're going to look for our main function. So if there is not a main function, this will not run because it will not be able to find this. So we're going to get our main function, what address that's at. we're going to create a new C function type that's returning an integer, and we're going to give it our function address of entry. So that's now our C function. So this is where we'll add in our time functions. So we'll do our st for start time. We're going to call this C function in Python, and whatever this returns is what our entire program is returning. So we'll save that to a result. And finally, I just have a print statement here, just as something nice to see when I run this code. It's just going to show what the program returned and how long it took to execute. And that'll help a lot when we try to benchmark this language with some Mandelbrot sets or Fibonacci sequence or something like that. So now that we have this, we make sure this run code is true. We should be able to python main.py, and we have officially ran our first Lime program. So all this does is returns a, which is 4. So we can do a times 2. So we're expecting 8. This program's returned 8. So now that we have the functions implemented, we have return statements implemented, block statements implemented, and we have the ability to run our program through an MCJIT compiler. So now you can do a lot of arithmetic operations. Unfortunately, we cannot call functions yet, reassign variables, and if statements. We got a lot of stuff to do. So we'll move on to our next episode. In episode 7, we're going to take on variable reassignment. So we're going to be able to take, let's say, let a equals 4, and then we're going to be able to set a equal to 15 times 5. And we could set a equals a divided by 2. We'll be able to reassign variables since we don't have constants yet. So that's it for this episode. Thank you guys for watching. If you are having any issues, you have any suggestions, comments, concerns, drop them in the comment section below. If you do have any issues, it's better to join our Discord. That link will be in the description. And I will see you in episode 7.